Welcome everybody. Today we're going to do some problem solving using function notation. And you've probably noticed that there isn't there aren't many differences between what we're doing now and what we did for the first four lessons of this unit, except the only thing is the notation. Okay, so we're no longer using that y equals notation, and we're now using f at x notation, which is the function notation. So again, we're just going to do one example today, and you've done this example in lesson 3 with that candle question, if you remember. And what it said, it was basically a candle manufacturer found that their long last candles melted according to the formula height equals -2 times t plus 12, and then the h was the height in centimeters, and t was hours. Okay, so the relation between height and time is described by an equation. Of course, there's the equation. Okay, but we can change this into function notation, and you see how it might make a little more sense now why we use function notation. All right, and again, this is going to be a function because the key thing here, there's only one output for every there's only one output for each input. Okay, so each input there's only one output. All right, let's get going here. So here's the new function notation. A candle manufacturer, okay, same question, melted according to the formula. Now here it is, h at t. So it's exactly the same as above, except where the way we can read this is saying, okay, what is the height at a certain time? H at t. What is the height of the candle at a certain time? In this example, the notation h at 4 is a simplified way of representing the height of the candle after 4 hours. So in other words, h at 4 really just means what is the height after or at 4 hours of burning. Okay, so let's go ahead and do this question. Use a graphing calculator to sketch the graph of the function. And again, you'll notice, let me first label this because with the information I have. So the time is going to go over here, and that is in hours, and the height of the candle is going to be over here, the height of the candle, and that's going to be in centimeters. Okay. All right, and again, I'm only going to use the first quadrant here because I can't have negative time and I can't have negative height. So I don't really care about the other 3 quadrants. Okay, let me get my calculator out and plug this in here. Negative 2t plus 12, and I'll graph this. And I'm just going to adjust my window. Again, I don't care about the negative value, so I'm going to make that 0. I'm going to make the y minimum 0, and I'm going to increase my height of the candle, which is the y max, to maybe 20, and see what that gives me. And let me just change my scale to go up by 2 and to go up by maybe 5 over here. Okay, graph that. All right, so I have 5. So this is 5 centimeters. Let me just do a quick graph here. 10, 15, 20, and then I'm going up by 2's here. So 2, 4, 6, 8, 10, 12 hours. We'll see if the candle lasts 12 hours. Well, it looks like it starts at 5:10, just above 10 here. Starts right about here, and it looks like it goes down to, well, that's the wrong thing. Looks like it goes down to 2, 4, 6, right about 6 hours, so somewhere around here. So I'm just going to go ahead and connect those right there. All right. So determine the value of h at 5. So let's go ahead and do that. So what is the height of the candle after 5 hours? Where h at 5 equals -2, and then instead of the t, I'm going to put in the 5 because that's what I'm told to do here, plus 12, and that comes out to be 2 centimeters. So let me go ahead and label that on the graph. 2 centimeters. Well, that's 5 here. 5 is about here, and then right there. There we go. That's part A, part B there. So write in words the meaning of this. Well, what this means that the candle is 2 centimeters when the height is when the time is 5 hours or after 5 hours. Okay, let's do some more here. Evaluate the following and explain their significance. Okay, so h at 0. So again, where's my so h at 0 equals negative 2, 0 plus 12. That's going to just be 12. So, and what is the significance of that? Well, that is the y-intercept. That's right over here. So that is, you know, when the candle is new. The candle is new. Okay. What is the h at 6? Well, h at 6, negative 2 times 6 plus 12 equals negative 12 plus 12. Well, that's 0, and that point is right here, and that is the x-intercept. And what that means is basically the candle is gone. Okay, the candle disappears after 6 hours. The height is 0 centimeters. Okay, so this is 12 centimeters as well. So the candle is 0 centimeters after 12 hours. After 8 hours, let's see. So h at 8 equals, let me get my smaller pen here. There we go. Negative 2 times 8 plus 12 equals negative 16 plus 12 equals negative 4. Well, that is that is impossible because the candle can be negative 4 centimeters. So that's, you know, the significance of that is it can be. That would be down here somewhere, right about under the 8 here. Let me do it in red. If this thing kept going under here, it would be right there. All right. How long will it take for the candle to burn down to a height of 7 centimeters? Okay, now they're asking us to work backwards. And I have, basically they're telling me what is the f at, sorry, made a mistake there. It's not f, it's h for height. So h at t equals 7 centimeters. So they're telling me the height, and I have to find the t. So I have to get t equals something, okay? So h at t equals 7. Well, if h at t equals 7, well, that's no problem because I know the equation. H at t equals negative 2t plus 12. And if that whole thing equals 7, well, I can just solve for t. Not much difficulty there. That's going to be 7 minus 12. That's going to be 5. Negative 5 equals negative 2t. And then t is going to equal 2.5 hours. All right. So to answer this question, how long will it take for the candle to burn down to a height of 7 centimeters? 2.5 hours. And that point, ladies and gentlemen, is right up here somewhere, right about there. Okay. All right, last question. State an appropriate domain and range for the function. Well, the domain, we can go, that's t. T is greater than and less than. So t is greater than, well, that's time. So it's going to go from 0. And what did we say? 6? 6 here was the t-intercept. So that's the 6 hours is when the candle dies. So and then h at t, which is the height of the candle, and then it goes from 12, I believe. Yeah, 12 centimeters. Obviously from 0, okay, because that's when the height is 0. Okay, thanks for watching, and see you next time.